So now that we have the reactions, we would want to just place their real values at the points of concern. That's point A, we have 23 kilonewtons, at point B 12 kilonewtons, and we have our external forces. So our interest is to find the shear forces, the values of shear forces at the various points, that is at point A, point C, and point B. So starting from point A, we can say shear force at A. Maybe we can do this, shear force at A. So at A, if we are holding the right hand side, we ask ourselves, the first force we see at point A is 23 kilonewtons. So look at the forces, we consider them one after the other. So this reaction, 23 kilonewtons, if you are holding the right portion, so you are looking at only the 23, how does it shear the beam? Does it shear it upwards or it shears it downwards? So our sign convention said if it shears it upwards, that's the left portion upwards relative to the right, then it's a positive shear force. So this gives us 23 kilonewtons. Now we come to point C. So at point C, shear force at point C. At point C, we expect to have two values, and the reason being that we have a point force here. So wherever we have a point force, we're going to have two values of shear force. And the first value would be at point C, you look at all the forces to the left of point C without considering the force at that same point, at the particular point. So I'll take it again. We are looking at all the forces to the left of C minus or without considering the point force at that point C. So having said that, we're going to look at the forces to the left of point C one after the other. So we start with this 23. So how does it shear the beam? So it shears it upward, okay, relative to the right. So we're going to have what? 23. So our next force would be the UDL. So that one is shearing what? The left portion downwards relative to the right. So it's a negative what? Force. So we have negative 10. And of course, with shear force, you always multiply by the span. So the span here is 3 meters. Let's put in the spans. This 2 meters, this 3 meters. So we have 10 times 3. So that's it. So this would have given us 23 minus 30. That's minus 7 kilonewtons. Okay. So the next point, we're going to look at the same point C, but this time around we'll look at all the force to the left of point C, and then we'll include the point force at point C. So all forces just before C, let's call it FC prime. So we're going to have what? The same forces, 23 minus 10 times, this 3. Minus 10 times 3, okay. Then you look at that same force. So that same force, the point force at that point C, of course, is sharing the beam downwards. That's if you consider the right portion. So we would have had minus what? 5. So this will give us negative 12 kilonewtons. Okay. Now we can look at the last point, that is point B. So we'll look at all forces before B. So just before B, FB. So here too would have had all these forces, this one, this. So we'll have the same thing here, 23 minus 10. That's the UDL times the span, 3. Minus this force, 5. So all forces just before B. That is all force to the left of B without considering the point force. So this would give us negative 12 kilonewton, of course. Then last force, FB prime, that is all forces to the left, that is all forces to the left of B, and then the force at B2 included. Okay, so that one too, we're going to have what, 23 minus 10 times 3 minus 5 plus 12. So this would give us 0. So we have all the values of the shear forces. So what we'll have to do next is these forces, we're just going to plot them. We'll plot them. So if this is our what, our 0 axis, so upward force is positive, downwards negative. So we say this point A, this point what, C, and this is point B. So here at point A, we saw the shear force to be what, 23 kilonewtons. So 23. Okay, so we can join that with a straight line. Then at point C, we have negative 7 and negative 12. So negative 7, that's somewhere down. So negative 7 is here. Then we have negative 12 just beneath it. Okay, so that means that we'll connect this point to this point this way. Then again we connect from here to here. So this was what, 7 negative, and this is what, 12 negative. Now we come to point B. So at point B we have negative 12, so that's the same value as this, so it will be a straight line, 12. So we're just going to connect this way. This gives us negative, this gives us positive. So this gives us the shear force diagram. We can just call it F. That's the shear force diagram of the beam, the simply supported beam ABC. And so looking at this diagram, you see that at a point between A and C, this point C, A and C, the value of shear force crosses the what, the 0 line. Okay, so this point is actually of interest to us, so we could call it maybe the distance from point A to that point where the shear force is 0, let's call it X, so that we can find what that force is, that distance truly is. Okay, so that's our shear force diagram again. And you see, looking at the original task, you see that where we have UDL, we have an inclined line. Okay, and where we don't have change in force, that is between point C and B, you have the shear force to be what, constant. And where you have the point force 5 kilonewton, you have a step equal to what, that value, that is 12 minus 7, 5 kilonewtons. So anytime we have a shear force diagram, this is how we could interpret the graph. So it means that the value of our shear force starts from here. Then as you go here, the values are reducing up to a point where it's 0, then it goes to negative, it comes to point C, it drops down, then it gets constant up to point B. That is our shear force. And as I said, the point where the shear force is equal to 0 is of interest to us. Okay, later we would get to understand that that is a point where we have our bending moment diagram, assuming a peak point, or let's say turning point. Sometimes is a maximum, sometimes is a minimum. So we need to find that point.